Okay, here's another Simulink tutorial, and we did an assignment a while back where we did a Fourier series, and we basically just created a bunch of sine waves and ran them into a summer, and then we weighted them and gave them the appropriate frequency. So it's kind of a brute force approach. You can see that on the on the YouTube videos under Fourier Series. Now this one I'm going to call Fourier Series 2, and it's going to show you a different way of doing that. Some students did it this way, and I thought it'd be kind of neat to explain it to everybody. So let's come down here and create a new model. Alright, so there, set up a new workspace here, and let's get some room to work. It's going to have a few more elements here. First thing I'm going to do is I'm going to put the time signal in there, or the clock. Where's the clock? Alright, we're going to put a clock in here. Okay, and then from a clock we're going to have an amplifier. Okay, so let's put a gain in there, and that's going to basically give me some different scaled clocks. And then I'm going to need to do the sine wave. So if I go back to math functions, there's a sine block that computes the sine wave. And then I can also just copy this gain, because I'm going to need two gains. And then again in the math operations I've got the sum of elements. Okay. And then here I am going to need all my scopes. Alright, so let's just put a bunch of scopes in there. So let's connect all these guys up and see if we can understand what they're doing here. Okay. And I'll connect all these guys here. Oops. Let's see, connect the sine wave to the gain and the gain to the clock. Alright, let's line them all up here. Get a nice neat line. Okay, so the first thing is let's try to figure out what this clock does. Well, the easiest way to figure out this clock is to drag another scope, and let's just put it over here. And what we'll do is we'll run the clock into that guy. Alright, so there you go. So we've got a clock. Okay, let's run that and see what happens. Well, there is the output of the clock. Okay. And let's maximize it, and then we'll save those settings. So really, when you think about that, the Simulink is going from 0 to 10 seconds, which we've got highlighted here. Okay. And then the clock just outputs a line that at 3 it's equal to 3, at 5 it's equal to 5, at 8 it's equal to 8, and at 10 it's equal to 10. So really this is, you can think of this as a function, f of t equal to t. So what's coming out of that clock right here is really just t. So think of this guy as a variable t. Alright, great. Now we have some gains. Well, let's put some gains in there. All right, let's open up this gain block and set up a little vector, and we'll do 1:3. Now what that means is I am going to have three different gains. Okay? So let's create another scope over here and see what's going out of this guy now. Okay? So what we can do here is run it again, and now I will open this. Well, let's put this guy underneath the first plot and take a look at that. Well, look what we have now. In the first one we had t, but now what I've got is I've got some gains. Let's open this up so we can see what the gains are, 1 to 3. So what I've done is I've taken the time signal, f of t equal to t, basically just t, and I've multiplied it by 1. So I had the yellow plot represents 1t, which goes from 0 to 10. Okay, there's 10 about right there. And then I've taken the next one and multiplied it by 2, so I've got 2t. Well, at 10 seconds, 2t is equal to 20. And then the cyan plot is 3t. At 10 seconds, we get 30. So what's coming out of this guy, you can kind of think of this as giving me t, 2t, and 3t. So now I've got three signals, t, 2t, and 3t. Right? Now when I put those into the next function, the trigonometric function, I'm going to get the sine of t, the sine of 2t, and the sine of 3t. All right, let's do a scope on that. Okay, so I'll run that guy into here, and let's run it again, and we'll open this window. Alright, let's put that right over here, kind of move this over to there, and we'll scale it, save it, and notice what we've got. At this point here we've got three sine waves. You know, in the previous gain block we got t, 2t, and 3t. Now we run into the trigonometric functions, and I've got sine of t, sine of 2t. Let me write that in here. I wonder if I can write that in here real quick. So coming out of this guy, you get sine of t, sine of 2t, sine of 3t, and then of course, you know, if we wanted more stuff, we could ... keep going. Okay. And then when you look at this plot, let's open it up a little bit bigger here. Yeah, we can kind of make it bigger, and we can observe that the yellow plot, well, let's see, there's one cycle on the yellow plot all the way out to 6 seconds. Okay. Then the purple plot would be sine of 2t, so we should have 2 cycles all the way out to 6 seconds. And in fact, we do. And the cyan plot should be sine of 3t, so we should have 3 cycles. 1, 2, and 3. There you go. So I've got sine of t, sine of 2t, and sine of 3t. All right, let's shrink that guy back down. Okay. And the next thing I want to do is now I want to amplify all those guys. Well, let's open up this amplifier. Let's make it a little bit bigger so you can kind of see what I put in there. And let's amplify the gain here. All right. I've got 3 signals coming in, so I need to give 3 gains. So we'll set up a little vector. Let's do a 1 on the first one, then how about a negative 1/2 on the second one, and then a 1/3 on the next one. So I'm alternating 1, 1/2, negative 1/2, 1/3. And you can kind of see them in that gain block. That's kind of neat. All right, once again, let's put another scope over here. And let's see what that guy does. Let's run it again. Double click that, and now let's put this guy down below. I wonder if I can get all these on the screen and you could still see them. Because what we're seeing now is we've taken, you know, our original sine waves, all of equal amplitude, sine t, sine 2t, sine 3t, and now we've kind of amplified them. We've amplified sine of t by 1, so the yellow one stays the same, but then the purple one got amplified by 1/2, and the cyan got amplified by 1/3. Okay, so yeah, we could draw these a little bit. Let's open them up a little bit. So we have the sine waves right there with equal amplitude, and then down here, oops, I don't want to do that. Yeah, I have them now scaled. 1 on the yellow, purple 1/2, and then actually a negative 1/2. You kind of see it flips out, starts negative, and then a positive 1/3 on the cyan one. All right, well, at that point, then I take those 3 sine waves. So coming out of this gain 1 element, I run it into a sigma sum of elements. And that takes all 3 of those signals and just adds them up in time. And then the output is going to be the scope right here, and that is going to be my Fourier series term. Let's double click that and see what happens. And there you go. You can kind of start to see a periodic nature of this guy. Coming up, we got 2 periods. It's kind of a ramp. Well, let's go back to this function now and kind of modify things. Let's put 10 terms in there. So first thing I can do is go back to my gain where I create t, 2t, 3t from the clock, which is just t. So what we'll do is we'll say, all right, let me create t, 2t, 3t, 4t, 5t, 6t, 7t, 8t, 9t, and 10t. Okay? Then I'll have to go to my gains, and I'll have to put 10 gains in there. So I've got 1/2. How about a negative 1/4, a positive 1/5, a negative 1/6, a positive 1/7, a negative 1/8, a positive 1/9, and a negative 1/10. So I've got 1, negative 1/2, positive 1/3, negative 1/4, positive 1/5, negative 1/6, positive 1/7, negative 1/8, positive 1/9, negative 1/10. Now, of course, you can't see them inside here anymore because there's just too many of them. Okay. And let's sum them up. So now, in this case, I should have a Fourier series with 10 terms. And there you go. Look at that. That Fourier series guy is starting to actually kind of look like a sawtooth. You know, a little bit. So let's increase it. Maybe go to. Now, what happens if we change the time base? 20. Is that going to mess us up? Well, let's see. Let's see what happens when we change the time base. No, it didn't mess it up. Everything seemed to work pretty good. You still get your periodic nature of your signal here. Now, because you've increased the time base and not the resolution, things are kind of looking chunky down there. All right? But anyway, that is another way of doing a Fourier series in kind of a slick approach. So let's run that again. And there you go. There you get your periodic pulse train. Okay? All right. Well, hope that was interesting, and we'll see you later.